Hi guys, a very good morning everyone. Welcome to the session and welcome to the end game. Yes, HAL 2023 examination is going to be conducted from 9th September onwards. Yes, the 9th to the 11th September, and we are already on to the 6th of September. Yes, so the team Electronics and Communication from BYJU'S Exam Prep, we are bringing you a super fast and non-stop question practice session so that you test and assess your preparation with respect to the HAL examination. And I already updated you earlier that it is clearly mentioned in the HAL website also that the syllabus of the examination will be in line with the GATE 2023 syllabus. Okay, so keeping all those points in mind, this session has been planned. We'll cover up the questions, okay, as per the syllabus of HAL and also matching with the level of the HAL examination. All right, guys. Right, so very good morning everyone. Keep joining and quickly share the session to all your friends so that everybody can join this quickly. Yes, I think. Chalo, let's get started then. Let's get started. To me, Sanjay Rathi sir, Saket sir, one by one, sequentially, we'll move forward and keep discussing the questions. Okay, and let me bring up the first question straight away. So, I'll be covering up the questions from digital control and signals, and then Sanjay Rathi sir will add on to other subjects. Okay. So very good morning, Ashok, Bhanu Prakash, Sagnika. Okay. Chalo guys, let's get started. And guys, whatever we discuss, okay, in the today's class with the question and solution, I'll share you the PDF. I'll share you the content in my Telegram group, okay, which you can join. I'll share you the link also in some time. And not only this today's PDF, but updates about other classes, updates about upcoming exams and notifications, other important concepts, doubt discussion, many of the activities you can participate. And also, guys, UPSC ESE 2023 mains results have been declared, and not only results declared, even the exam interview dates are also announced. The interviews are starting very soon. So if you're one of them selected for the mains examination, so you must definitely be looking for mock interview guidance right now, and it's not only about guidance. Okay, the BYJU'S exam prep is coming up for you with the free mock interview, the live mock interview. Okay, face to face with a panel which is very similar to that of an engineering services UPSC panel. Okay, so if you are one of them selected, you can share a result. The link is in the description and the team will coordinate and book your appointment and slot for this mock interview. Okay, chalo, here it is, the first question for all of you guys. Let's get started and let's get moving ahead. Okay. If 225 in base y is 165 in octal, what is the value of the radix base y? What is the value of the base y? Okay, so very fundamental question it is, but yeah, HAL will mostly focus on fundamental question. Of course, some can be tricky as well. Okay, so we'll have a mixture of variety. Okay, so 225 in base y is 165 in base 8. 225 in the base y is 165 in the base 8, and we know that we can designate the position from the LSB, that is 0, 1, 2. This also becomes 0, 1, 2. So, and then I can write down this number as 2 into digit into base pi. See, if two numbers are equal, they are in different number systems, they are in different bases. Okay, but if they are equal, so ultimately their decimal conversion is also equal. So, if I convert into decimal, this is digit into base power position. Base hai y position ho gaya 2. Okay, then 2 into y power 1, and then you have 5 into y power 0. Okay, on the right hand side, I will be having 2 into 8 power 2 because the base of the right side is known, that is 8. Okay, and then plus 6 into 8 power 1 plus 5 into 8 power 0. So we're going to get a simple equation here. 2y square plus 2y plus 5 is equal to 2 into 64. Sorry, that is 1 only, not 2. Why I wrote 2, I don't know. It is 1 into 6 square, 1 into 8 square. Okay, so this is equal to 64, 6 8s are 48, and plus 5. Okay, so 5 getting cancelled. Now you have the equation 2y square plus 2y is equal to 112. So ultimately cancel by 2, y square plus y equal to 56. You bring on the left side, minus 56 equal to 0. Clearly factorize as y plus 8, y minus 7 equal to 0. So y ka answer minus 8 or plus 7, but the base cannot be negative. The base of the system cannot be negative. So y equal to 7 is the last answer. The base of the number system has to be 7. Okay, the correct answer is option number 8. That should be the 7. The correct answer is option number A. That should be 7. I should move ahead to the next question now. Consider the following circuit. Okay, which one of the following gives the function implemented by the MUX-based digital circuit? A very simple question on MUX. A very simple question on the MUX. तो इसको देख लेते हैं, इसको solve कर लेते हैं. Okay, so what it is? Now select lines are C2, C1. Okay, and if they are 0, okay, if they are 0, C2, C1, we can assume it to be S1, S0. I mean, of course, we'll assume C2 to be MSB undoubtedly. Okay, we'll assume C2 to be MSB undoubtedly, because MSB bit position should be higher as compared to the LSB. Okay, so at 0, 0, right? At 0, 0, that is, we write C1 bar, C2 bar, C2 bar, C1 bar multiplied by the I0, which is equal to 1, right? At 0, 1 combination, 0, 1 means C2 bar into C1. We'll take the I1, which is nothing but A into B. At the 1, 0 combination, C1, C2 bar, at the 1, 0 combination, I should be taking I2, and at the I2, what is connected is some variable S. Plus at the 1, 1 combination, 1, 1 means C2, C1, I'll be connecting I3, and that is just grounded. That is just grounded. That is equal to 0. Okay. Right. So what it is, this is a simple one only. C2 bar C1, no further simplification required, I think, cannot be done. C2 bar C1 AB. Okay, C2 bar C1 AB and plus C2 C1 bar S. C2 C1 bar S. Yeah, very, very clear. D is the correct answer. Yes, Bhanu, correct answer. It is very evident that the correct answer is equal to D. Okay, moving ahead to the next question. In the given sequential circuit, initial states are Q1 equal to 1 and Q2 is equal to 0. For the clock frequency of 1 megahertz, what is the frequency of the signal Q2 in kilohertz? What is the frequency of the signal Q2 in kilohertz? Right. Yes, Martina, correct answer. Okay, so initial state is given to you. That is Q1 is 1 and Q2 is equal to 0, and we need to determine the frequency of the signal Q2, and Q2 is the MSB. Okay, that means you have to talk about the frequency of Q2. QT को MSB consider कर सकते हैं, and then frequency at MSB is given by clock frequency divided by mod number. So we need to calculate mod number of states. अच्छा, ये ध्यान रखना है यहाँ पे. So what are the equations actually? So if you look into Q1 plus is equal to D1. But what is D1? It should be equal to Q2. What is Q2 plus? It is equal to D2. That is the equation of D flip-flop. Q plus equal to D. But what is the value of D2? The D2 is Q1 bar. The D2 is equal to the Q1 bar. Okay, so what do I have here is, if I start writing Q2, Q1, okay, if I start writing Q2, Q1, it is initially 0, 1. Okay, it is initially 0, 1. It is initially the 0, 1. Q2, 0, Q1, 1. But what is the value of Q1 plus? It is equal to Q2. Q1 plus is Q2. So what is the next state of Q1? Will be the current value of Q2. And what is Q2 plus? It is Q1 complement. So whatever is the current state of Q1, take the complement and put it here. Okay. Take the complement and put it here. So ये तो 0 यहाँ पे directly आ गया, and this will be complemented and put as 0. Okay, now next, this 0 forward and this 0 complement 1. Next, this 1 forward and 0 complement is 1. Okay, next, this 1 forward and this 1 complement is 0. We come back to the initial state. We come back to the starting state. Okay, yeah, that is what it is. That is what it is. Okay, so 0, 1, 0, 0, 1, 0, 1, 1. All 4 states are counted. All 4 states are counted, and then I repeat. Okay, so how many different states are here? How many different states are available? Okay, how many different states are available? 4 different states are available. It is mod 4. How many different states are available? It is the mod 4 case, very clearly. It is the mod 4 case. So then what is the answer? If it is mod 4, the frequency at the signal Q2, okay, sorry. The frequency at the signal Q2, which I have taken as the MSB part, which I have taken as the frequency at MSB, it is given by the clock frequency divided by the modulus number. Clock frequency 1 megahertz hai, that is 1 into 10 power 6, and divided by the mod number is 4. And we are looking for the answer which is in kilohertz. Okay, which is in kilohertz. So 1000 by 4, it is 250 kilohertz is the right answer. 250 kilohertz is the right answer. Correct? 250 kilohertz is the right answer. So let me create the options here actually. For HAL, we should definitely be having the options. Okay, so I'll mark the option as A. Correct answer is option number A, 250. Correct. Yes, Bhanu and Martina, correct answer. 250 kilohertz is the correct answer. Next question should be ready for you now. Here it is. What is the frequency of pulse at the point C in the circuit? What is the frequency of the pulse at the points C in the circuit? At the point C in the circuit. Tell me. What is the frequency of the pulse at the point C in the circuit? At the point C in the circuit. बोलिए क्या होगा? So frequency at pulse. Again, frequency division का concept है. Previously you had to count the number of states, but here you just need the basic knowledge about the number of states of ring counter. What is the number of states of ring counter? If it is a 10-bit ring counter, the number of states will be 10. Let's say it is N1. Then in cascade we have N2. Okay, this is a 4-bit Johnson counter, and the number of states of Johnson counter are double the number of bits. So it is going to be 8. Okay, and third one is clearly mentioned, there is a ripple counter counting 10 states. It is clearly mentioned mod number 10. Okay, and whenever counters are connected in cascade, whenever the counters are connected in cascade, their mod numbers are multiplied here. So it should be 10 into 8 into 10. So overall modulus number of the counter is 800, and then the frequency at the final bit C will be equal to the clock frequency, that is 10 megahertz, the input frequency, divided by 800. So definitely 10 into 10 raised to the power 6 by 800 kilohertz में भी ले जाएंगे. Okay, so 10 power 3 separate, and then kilohertz or megahertz, definitely kilohertz. This is cancelled. 100 by 8, correct. 12.5 in terms of kilo. 12.5 kilohertz, option number B. Option number B. Yeah, Bhanu Prakash, very correct answer. Option number B, that is the 12.5 kilohertz is the very correct answer. Okay, 12.5 kilohertz is the very correct answer. Move करते हैं next question की तरफ. What is the maximum conversion time for an n-bit counting type ADC? Maximum conversion time. The maximum conversion time. Because for a counter type ADC, the conversion time depends on what? The input that you are converting. Okay, good afternoon, Chinmoy. Okay, but what is the maximum possible conversion time? The highest count, 2 power n minus 1. It's a direct factual question, you can say, and expected HL में आएंगे कुछ calculative and some direct questions. 2 raised to the power n minus 1. Yes, Martina, correct answer. Okay, it is 2 raised to the power n minus 1. The maximum count of a n bit is 2 power n minus 1. 2 raised to the power n whole by this one. Okay. Next one. In a memory map of RAM, the lowest and highest address of the memory is 1000 and 2FFF in hexa. What is the capacity of the memory? So now you are given the first, the lowest and the highest address. Okay, the first and the last address. Okay, so what is the memory size in hexa? Okay, in hexa, what is the capacity of the memory? Okay, it is given by the last address minus the first address. Is that? Suppose there are the addresses starting from 1 to 10. There are the addresses starting from 1 to 10. How many total address? There are address from 1 to 10. So we know that these are total 10 address. Okay. But do you write 10 minus 1? If you write 10 minus 1, you have discarded this. Now you have subtracted it. Okay. And then you get 9. Actually 10 addresses. Okay. So 10 minus 0. 10 minus previous. Yeah, ऐसा बोल सकते हैं 10 minus 1 plus 1. Okay. So similarly, it is 2FFF minus 1000 plus 1. ये ध्यान रखना. Plus 1. Okay. Because we have to count from 1000. So we have to subtract number before it. Yeah, if you are subtracting 1000, add one location extra. Okay. So what it is going to be equal to now? First of all, see, 2FFF minus 1000. Okay, 1 subtract here, 2 minus 1 is 1. Rest it is FFF. So 1FFF plus 1. What is 1FFF plus 1? Guys, hexadecimal. What is 1FFF plus 1? What is the next count after F? Okay, 0. After F, 1, 0. So 0 carry 1. Again F plus 1, 0 carry 1. F plus 1, 0 carry 1. 1 plus 1, 2. It is like, always you should remember, if it was decimal, if you are in the decimal number system and if you write down 1999, okay, if you write down 1999, what is going to be the next number? Because in decimal highest 9 hota hai. So in decimal, if you are at 1999, okay, so next number will be 2000. Same is the case here. If you're at 1 triple F, next will be 2 triple 0. Next is going to be 2 triple 0, but that is hexa 2 triple 0. Okay, hexa 2 triple 0. Now, hexa 2 triple 0 को size बताना है इसका decimal में. So, if you want to convert to decimal, you know, this is position 0, 1, 2, 3. Okay, 2 into 16 power 3. That's it. Rest will be zeros only. Okay, 2 into 16 power 3. 2 into 16 power 3. Rest will be 0, 0, 0. No need to add. Okay, but since we need it in form of kilobyte, options are clearly in kilobyte. So no need to completely solve it. What you can do, you can make an arrangement. 1 kilobyte is 2 power 10. 1 kilobyte is 2 power 10. So you can write this 2 power 16 as 2 power 4 whole power 3. And then you have 2 power 4 power 3, 2 power 12 and 2 separately. Total 2 power 13. Okay, you have total 2 power 13. You have the total 2 power 13. ठीक है, capacity of the memory chip. अच्छा, definitely there is something which is not mentioned here. Okay, the capacity of the memory chip. I can tell you the number of addresses actually. There is something incomplete with the question, I will tell you honestly. Okay, I can tell you the number of addresses, but how many bits stored at the address is not mentioned. So maybe the data is missing. Let's assume it to be the data. Okay, let's assume to be a data of 8 bits. Let's assume a data to be of 8 bits. Okay, let's assume the data to be of 8 bits. So you have 2 power 13 location. That's what you are able to say. 2 power 13 location you have. Correct. Achha, 2 power 13 will be 2 power 3 into 2 power 10. Into 2 power 10 and 2 power 3 is 8. Okay, and 2 power 10 is how much? 2 power 10 is K. It is 8K. Right. Now, because every particular place will store 8 bits and 8 bits is already a byte. 8 bits is already a byte. So I can write down 2 kilobytes. 2 kilobytes. Sorry, 8 kilobytes. And 2 power 3, that is 8. 8 kilobytes. So option number D. Yes, Martin and Bhanu, correct. Okay, it is option number D. It has to be mentioned. Data of 8 bits. Okay. Where? Okay, at one location, I am able to show the data of the 8 bits. Chalte next question ki taraf, dear. Okay, let us be moving ahead to the next question. Here it is. For the block diagram given below, determine the sensitivity. Okay, coming to a control system question here. So kya hoga? What is the sensitivity here? See, sensitivity, ST beta. Okay, what is the ST beta? T bole to transfer function, okay? T bole to transfer function. Okay, yeah, Chenmoy, correct. Okay, so when you are calculating ST beta, first of all, we need to calculate transfer function. That I will do so. But what is the meaning of ST beta? Sensitivity of the transfer function with respect to the B. And it should be del T by del beta. And here I can write it as beta by T. Beta by T into del T by del beta. Okay. Now, what is the transfer function? Okay, we know that it can be calculated as G upon 1 plus GH, and G is beta. Beta by S plus 1 whole divided by 1 plus beta upon S plus 1 is multiplied by the 1. So what is the transfer function? S plus 1 se multiply karenge. So I get beta upon S square, then plus S plus beta. Okay, that is the transfer function. Okay, so what is the sensitivity now? ST beta, as I told you, it is beta by T into del T by del beta, or it is beta upon T. Put down the transfer function, that is further beta upon S square plus S plus beta into del by del beta of the transfer function, and the transfer function is beta upon S square plus S plus beta. So we need to do a quick differentiation, that we will do so, not a problem. Here beta cancelled, 1 upon S square plus S plus beta को ऊपर shift कर दिया, तो S square plus S plus beta. Now numerator by denominator, beta is in both the place. Okay, the differentiation of numerator by denominator, First of all, okay, let me square up the denominator. So s square plus s plus beta whole square. Okay, then denominator constant s square plus s plus beta into differentiation of numerator with respect to beta is 1 minus beta constant differentiation of denominator. Differentiating with beta, so s is constant and again beta differentiation is 1. Okay, so this looks like one of this term is going to be cancelled. S square plus s plus beta minus beta cancelled. So the final answer is coming up, dear. That is s square plus s divided by s square plus s plus beta. I think that's it. We are done. Yeah, s square plus s upon s square plus s plus beta. S square plus s. Yeah, the option number D. We can take the s common and then the option number D. Clear, everybody? S square plus s plus beta. Okay, Puneet, check it up. It is not s beta. There is no s beta term coming up separately. No. Or did I miss something? No, na? Beta by s, s plus 1. So beta by s, s plus 1. No, correct. It has to be only beta. It has to be only beta. Okay, Puneet, just recheck it. Small difference here. It is s, s plus 1 plus beta. No extra s beta. Okay, ji? Chalo, done hai. Correct hai. Okay. Yes, Bhanu D. Moving ahead to the next one. Find the transfer function C by R of the system. Find the transfer function C by R of the system. Nikal lete. Find the transfer function C by R of the system. Okay, G1, G2 upon 1 plus G1, H2, G1, G2 upon 1 minus G1, H2, etc. So let's do it up quickly. Now we have the transfer function. Okay, we have the block diagram actually given. Okay, we have the block diagram actually given. You can use the BDR rules or you can, quickly convert it into the graph. Okay, I have the input R. This is my summing point. Next takeoff point in between. This is G1. Then I have the next summing point. In between there is the gain G2. Okay, and then I have the output C. Okay, and yahan se jaake I land it here. This is also in the forward path only H1, and this is coming here in the negative feedback path. So I'll call it as minus H2. So clearly there is only one loop here. There is only one loop available here. Okay, there is only one loop available here. Agar main closed loops ki baat karu. Okay, there is only one. There is only one, and that is G1 into minus H2. Clear? There is no other loop possible. That is minus G1 H2. And agar aap forward paths ki baat karo, if you want to write down all the forward paths, so clearly there is this one horizontal path. Okay, P1, which is G1, G2, and there is one alternative path from the top, and that is P2, and that is nothing but H1. So there are two forward paths. So final C by R as per the Mason's gain formula is going to be P1 del 1 plus P2 del 2 is divided by delta. Okay, there is only one loop, so delta is very simple. Achha, what about delta 1, delta 2? If you erase any of the forward path, how do you calculate deltas? How do you calculate deltas? It is the path factor. It is the graph determinant of the remaining graph after that particular path is erased. So if you erase this particular path, if you erase this path, okay, first forward path, then the loop is over. Then the loop is over, delta 1 ka value 1 hoga. And even if you erase this second path, okay, so this node goes away, na? Then also the loop will be open. Then also the loop will be open only. Okay, then also the loop will be open only. So both the path factors are 1 because whenever there is no loop, the graph determinant is 1. Na? Okay, the graph determinant is just 1. Na? So P1 plus P2 karna hai. That is G1, G2 plus of H1 divided by the delta. So there is only one loop. Okay, so there is one loop. So no point of touching, non-touching. Only 1 minus L1 has to be done. So that will become 1 plus G1, H2. That will become 1 plus G1, H2. And now we just have to go and match the option. G1, G2 plus H1. Okay. And 1 plus G1, H2, option number D. G1, G2 plus H1 upon 1 plus G1, H2. 1 plus G1, H2. Correct answer is D. Okay. Yes, Martina. Correct answer for 8th is D. Done. Okay. A basic question. Okay. On the transfer function. Next question. Number 9. Okay, next question, number 9 here. Yes, Chinmoy, correct answer. Great going, all of you. By a suitable choice of the scalar parameter K, the system shown in the figure below can be made to oscillate continuously at a frequency of what? Continuously at a frequency of what? Okay, frequency of oscillation, and it's going to be a third order system. Okay, from RH, you can decide. What is the characteristic equation? The characteristic equation is 1 plus K upon S, S plus 4, S plus 16 equal to 0. 1 plus K upon S, S plus 4, S plus 16 equal to what? Equal to the 0. Okay, so when I'm going to simplify it, I'm getting S cube plus 4 plus 16, 20 S square plus 4 into 16, 64S. Okay, 64S, correct, plus K equal to 0. Now, actual method that you require would be RH criteria and then row of 0, auxiliary equation, everything will come. But at least for a cubic equation, I've taught you earlier also in my sessions also, cubic equation is one common case, and there is a shortcut for the cubic equation. And the shortcut for the cubic equation, for the system to be oscillatory. Okay, I want the system to continuously oscillate continuously. That means you are talking about the system which is marginally stable. Talking about the system which is marginally stable, and for the system to be marginally stable, the product of means should be equal to product of extremes. For the system to be marginally stable, okay, the product of extremes is equal to product of means. Okay, so I can get the value of K is 64.1280. Okay, now they're not asking the value of K. Okay, they're not asking the value of K, but what is the frequency of oscillation in radian per second? Now, what is the auxiliary equation? Whenever the system is marginally stable, there will be a row of 0, there will be an auxiliary equation. And again, what is the shortcut of auxiliary equation in cubic equation? Okay, you have to take auxiliary equation is always even power equation. Na? So you can take 20S square directly. Even power means 20 square, and alternate mein plus K equal to 0. Right. Alternate में plus K equal to 0. So I have 20S square plus K equal to 0. So I have 20S square plus K, which is 1280 equal to 0. So what is the value of S square? Again 20 get cancelled, and minus 64. So what is S? Plus minus J. Under root of 64 is 8, or I can call it as plus minus J omega N. Okay, for auxiliary equation, the roots are plus minus J omega N for oscillatory system. So omega N is 8. What is the frequency of oscillation then? The frequency of oscillation is 8, option number A. Okay, yes, Bhanu, correct answer. It is going to be option number A. It is going to be option number A. Okay. Otherwise, you can also solve it by the complete route array if you're not aware about the shortcut, but it is cubic. Better to remember the shortcut because commonly questions are there on cubic, okay, directly, indirectly. Okay, yeah, sometimes use useful calculation in root locus indirect problem. So you should know about this. Okay. Yes, Martina, correct answer. Moving ahead to the next one. Here it is the 10th. The phase crossover frequency of the transfer function. Phase crossover frequency. The frequency at which the phase crossover frequency, it is the frequency, okay, at which the phase of the system, okay, the phase of the system, that is angle GJ omega, becomes minus 180 degree. Becomes minus 180 degree. Okay, so what is the GJ omega with me? This is the GS given to me. So it's going to be 10 divided by J omega into S plus 1 or 1 plus S, 1 plus J omega whole square. So what is the angle part? What is the angle GJ omega? What is the angle GJ omega? Numerator is a positive real number, so 0. Denominator J omega, pure imaginary, 90 degree. Okay, minus for every denominator term, minus. Okay, 1 plus J omega. What is the phase of 1 plus J omega? Tan inverse omega. Tan inverse omega. Acha, but square hai, so 2 times aayega. Tan inverse omega plus tan inverse omega. Okay, so 2 tan inverse omega. ठीक है जी. So what you want is minus 90 minus 2 tan inverse of omega is minus 180 degree. So I am getting 2 tan inverse omega minus to सब जगह cancel हो गया. 2 tan inverse omega is 90 और eventually tan inverse omega is equal to 45 degree. Acha, which omega? This happens at omega p. So let me directly put down omega p. At omega p, the phase is equated to minus 180 degree. So what is omega p? It is tan 45 degree, which is 1. It is equal to 1. The correct answer is option number A. Correct answer is the option number A. Yes, Bhanu and Martin are correct answer. Okay. Okay. ठीक है. Yes, Raj Kishore, we'll plan that also. Just don't worry. We'll plan that also. Okay. ठीक है. अच्छा, in herds है ना? Sorry. In herds है. मैंने भी ध्यान नहीं दिया. I just noticed the comment box. Raj Kishore. Yeah, we'll plan, Raj Kishore. If possible, we'll try to plan within a day only. ठीक है. चलो. So, yeah, that is omega p equal to 1. That is the omega p equal to 1, but radian per second. ये ध्यान देना है यहाँ पे. That is radian per second. So what is the fp? It is going to be 1 upon 2 pi omega by 2. So अगर hertz की बात की जाए तो that is the option number C. That is the option number C. In the hertz, it is the option number C. Done है? Correct. Okay, so we'll put it as C. In hertz, clearly mentioned the next question, number 11. Here it is. Okay, number 11. It is given that x dot t is equal to ax plus bu and y is equal to cx. Okay, a state space model has been given to you. A state space model has been given to you. Okay, you are given x dot. Okay, let me write it here separately. You are given x dot is equal to ax plus bu y is equal to cx. ठीक है. ठीक है. ठीक है. अब देखो. It is asked in hertz, Chinmoy. देखना ना, hertz में बोला है. That is why it's C. Okay. Now, whether the system is controllable and observable. If you go by Kalman's test, it is lengthy. 110% for the third order system. Kalman's test is lengthy. Okay. Kalman's test तो lengthy होगा. But can you notice the form of this? Can you notice the form? What is the model? ये पूरा ही लिख देता हूं यहाँ पे. What is this model? By looking into the matrix A. Okay, looking into the matrix A, it is the matrix which comes in the controllable canonical form. Okay, minus A0, minus A1, minus A2. Okay, and then first column 0, 0. And here you have the identity matrix. I divide the controllable matrix in the 3 different parts. Yes, and if you want, okay, see, the state space analysis is an important topic for all competitive exams, well, especially for GATE as well. So I have one complete marathon. You can just search by my name and you can learn everything. Okay, around 3 hours video it may be, and you can learn everything about the state space models there. Okay. So this is nothing but a CCF model. CCF is controllable canonical form, and controllable canonical form mein the system is controllable. That is why we name it as controllable canonical form. The system is always controllable. The system is always controllable. But still observability के लिए also if you apply Kalman's test, again it becomes lengthy. एक जगह टाइम बचा है, दूसरी जगह स्पेंड कर दिया. So what is the trick of observability for controllable canonical model? For controllable canonical model, वो भी आपको बता देता हूं. So what you have to do next is calculate the transfer function of this. Calculate the transfer function of this. How is the transfer function given, guys? ध्यान रखना. This is what we call this term as B, and we call this term as C1, C2, C3. ध्यान देना. B into C1 is the constant term, so we can start from here. C3s square plus C2s plus C1. Okay, yeah, जैसा भी लिखना चाहो. C1 is the constant term actually, you can say. Okay, C1 is the constant term. Okay, C1, C2, C3. C1, C2, C3 divided by S cube. Okay, now definitely it's going to be cubic equation, and this is minus A0, minus A1, minus A2. Okay, this is A0. That is a constant term. ठीक है. ओके, तो A0 का वैल्यू 2 होगा, प्लस रिवर्स चलेंगे, प्लस देन द टर्म 3s प्लस go reverse again. Next will be the 4s square. Next is the 4s square. Next is the s cube. This is how the equation it is. Okay. अच्छा, यहाँ पे भी मैं सारी वैल्यूज जनरली रख देता हूँ ना. Okay, so this is what A0. This is A1s. This is A2s square plus s cube plus s cube. Okay. So now if you put down all the values, you are getting 2, right? Only C1 is available 1, C2, C3 is 0. Okay, C2, C3 is 0. Okay. Okay, then you have s cube plus 4s square plus 3s plus 2. Now, what is the trick for observability? Okay, what is the trick for observability? See, whenever a system is in CCF form, it is always controllable. Then you write down the transfer function, which is easy. If you have studied CCF, writing down this transfer function is easy. If there is any pole zero cancellation in the transfer function, then it is not observable. But do you have any pole zero cancellation? Here, there is no pole to zero cancellation. Actually, koi zero hai nahi na, numerator is just a fixed number. Okay, so there is no zero, so it cannot cancel with anything. So ultimately, I can say there is no pole zero cancellation. And in the CCF model, whenever there is no pole zero cancellation, the system will be observable. But if there is a pole zero cancellation, system will not be observable. The system will not be observable. Yeah. So it is option number A, controllable and observable. Controllable and observable. Okay. Rahul, maybe you can expect 3-4 questions. They haven't specified separately, but yeah, at least 3, 4, 5 questions tak aap expect kar sakte ho. At least. Okay. I think they are more focused on the technical part. That's what I believe. Okay. Chaliye, let's move ahead to the next question. This is in the option number A, controllable and canonical is the correct answer. Okay, then we have 12. Find the asymptotic Bode magnitude. Find the asymptotic Bode magnitude plot shown below. The system transfer function can be. What can be the system transfer function if this is the asymptotic Bode magnitude plot is given to you? Okay, asymptotic magnitude plot is given to you. Okay. Yes, Chinmoy, Martina, correct. Bhanu, correct. Rahul, correct. Okay, for the previous one. Now, very clearly, okay, you have a critical frequency here. Okay. Okay. Sorry, you have a corner frequency here, and that is due to 0. Now, what is the slope here? Please note, 0.1 se 10. 0.1 से 10 कब आएगा? When you multiply 100. Okay, 100 बोले तो 2 decades. 100 is 1, a factor of 10 is a decade. So it is 2 decades. And the magnitude change is how much? यहाँ पे आ जाते हैं. How much is the magnitude change? 0 to 40. It is 40 decibel. And as I already told you, this is 2 decade. Okay, so what is the slope of this line? It is the change of magnitude 40 decibel corresponding to 2 decade frequency change. So this is known as 20 decibel per decade is the slope. Okay, so I can say that it is omega. This is the 0.1 frequency, which is the corner frequency due to a single zero, right? So what is available here? There is a single zero because the slope changes by plus 20 only. Now the slope was plus 20 and now the slope becomes 0 because it is parallel to x-axis, and that means there is a reduction of slope now. Slope the plus 20 now becomes 0. So there is a reduction of minus 20. So this is also a corner frequency, but because the slope reduces by minus 20, this is the corner frequency due to a pole. Okay, so there is one simple 0, there is one simple pole. Okay, there is one simple 0, but there is one simple pole. Acha, moreover, ठीक है, इसको थोड़ा सा हम broaden up करके देखते हैं. See, this is the plot and then it was increasing. The ramp and then like this. Okay, so looking into the initial part, what is the initial slope? Clearly, initial slope is 0. Okay, that means the number of poles at origin will be 0. There are no poles at origin. Okay, so generally we should write down the transfer function. Okay, Okay, GS या GSHS जो भी बोल दो यहाँ पे, some constant k into a 0 term 1 plus ST1 divided by s raised to the power n into the pole terms 1 plus STA. But I have only one 0 and I have only one pole. Okay, I just need to substitute there. Acha, what is the value of the time constant? Okay, so I have a 0. Having the time constant is reciprocal of the corner frequency because corner frequency is reciprocal of time constant. So I have 1 upon 0.1. Okay, so time constant T1 is 1. There is a pole and let's say its time constant is TA and that is reciprocal of its corner frequency and this is 0.1. So what is the value of K? K भी निकाल लेंगे अभी हम. Right, what is the value of K? K भी निकाल लेते हैं. Okay, so I have K 1 plus S T1. T1 is 10. Okay, so 1 plus 10s divided by s raised to the power 0. There is no pole at origin. Initial slope is 0. Okay, into 1 plus sta. Okay, into 1 plus 0.1s. Only thing I need to figure out is k. Acha, will the options help me? Acha, only options can help me, yaar. Correct. Khatam ho gaya. Option number A then. 1 plus 10s upon 1 plus 10s upon 1 plus point s. K का value 1 होना चाहिए. K का value then 1 होना चाहिए. Is it so? I doubt. Is it so? I doubt. अच्छा ठीक है. हाँ नहीं, यहां से K का वैल्यू निकालेंगे ना. सॉरी, I think there is something not going good here, because जो initial magnitude है, if you want to write down the initial part, if you want to solve for the initial part, okay, initial part, the magnitude is given by, for initial part, minus 20 n log omega plus 20 log K. Okay, n का वैल्यू तो 0 है, but even the initial magnitude is 0, dear. If the initial magnitude is 0, this becomes 20 log K. हाँ, करेक्ट तो है. Initial magnitude 0 given था ना. Fine. Okay, yes, तो K is equal to 1. Log 1 is 0. Log 1 is 0. No, K is not 100. Initial magnitude was 0 only, ना, तो correct है. Okay, तो K का वैल्यू 1 है. Right. K is equal to 1 as we found out. So the final answer is simply 1 plus 10s is divided by 1 plus 0.1s. 1 plus 10s divided by 1 plus 0.1s. 1 plus 10s divided by 1 plus 0.1s. Option number A correct. Just to verify, calculate it. Otherwise, option itself is sufficient to comment that answer is A. The option itself is sufficient to say that the answer is A. Okay? K is 1. Correct. K is 1 only. Yes, Bhanu. Okay, the correct answer, Martina, Bhanu. Correct. Okay, moving ahead to the next. Okay, yeah, some fundamental signals question. Okay, so I have an integral minus 3 se 3 t delta t plus delta t minus 2 plus delta t minus 5. Okay, now we can directly use the property that whenever there is a function ft, integral ft into delta t minus a. Okay, integral ft into delta t minus a dt is given by the formula f of a. You can put a equal to inside the function. Okay, but provided the limit t equal to a, okay, within the limits. If t equal to a within the limits of integration. Otherwise the answer is 0. The delta t equal to 0 पे impulse है. Delta t minus 2 is at t equal to 2. Delta t minus 5, that is at t equal to 5. So this one is outside the limit because the limit is minus 3 set 3. Okay, the limit is minus 3 set 3. Okay, so what is going to be the value of the integral? I can write it as integral minus 3 set 3 t delta t. Okay, plus dt plus integral minus 3 se 3. Okay, again t delta t minus 2. Okay, dt and plus 0. Last one, directly writing 0 because the impulse is outside the limits of integration. So now I have the answer. Now you have to substitute the value of a in the function. Function is t. Okay, but function is t. Okay, but you will substitute t equal to 0. Similarly, next the function is t, but you are going to substitute t equal to a, which is 2. So first wala bhi 0 ho gaya. 2 is the final answer. 2 is the final answer. Option number C, dear. 2 is the final answer. That is option number C. Correct, Rahul and Bhanu. The correct answer is, final answer is 2. Correct and final answer is 2. Okay. The energy of the signal is, okay, energy of the signal is no prem. That is why we are dealing in that level only. What is the energy of this given signal? 2ut plus 1. So you have to quickly sketch up this particular signal. Okay, you have to quickly sketch up this particular signal here. Okay, this is t. This is f of t. 2ut plus 1. 2ut plus 1. Okay, the units of function starting from t equal to minus 1 with the amplitude 2. Okay, 2ut plus 1. Okay, if only 2ut plus 1, I'll go till infinity, but there is a change. Minus 4ut. Okay, 4ut. Ut starts at origin and the amplitude is minus 4. So this is 2. Okay, and then you have to take it minus 4. So 2 minus 4, kahan tak chala jayega? It will be minus 2. Okay, minus 2. Okay, but now there is another unit step at t equal to 1 and whose value is plus 2. So minus 2 plus 2. Now after this, minus 2 plus 2, after this the amplitude is going to be 0. Okay, ye minus 2 kaise aaya? This was 2 minus 4. Okay, and this is 0 because there was this minus 2 now added with plus 2. Okay, this is how it is. This is how it is. Okay, now what is the energy of the signal? What is the energy of any triangular portion? What is the energy of any triangular portion? Okay, any triangular बोल रहा हूं, rectangular portion, sorry. What is the energy for any rectangular portion? It is given by amplitude square into duration. Directly you should use that. Amplitude square into duration. Okay, so this will be 2 square into duration have 1. And for this one, whether it is minus 2, doesn't matter. It is still plus 4 because amplitude squared up. So 4 plus 4, answer should be 8. Option number B. The correct answer is 8 joules. The very correct answer is option number B. That is the 8 joules. Okay, next question ready for you. Number 15. Let the signal xt have the Fourier transform x omega and let the signal yt is equal to d by dt of xt minus 3. Find out the Fourier transform of yt in terms of x omega. Fundamental property question. Fundamental property question. Okay, let the signal xt have the Fourier transform, that is x omega. So what is the Fourier transform for xt minus 3? Time shift property will be applied. Whenever there is shifting in time, there is the phase term in frequency domain, exponential term in the frequency domain. So that becomes x of omega e power minus j3 omega. X of omega e power minus j3 omega. Okay. Now, the derivative property. Okay. When you take a derivative of any signal, the Fourier transform is nothing but simply multiplied by j omega. So it's going to be simply j omega into the previous one. That is j omega x omega e power minus j3 omega. So it is the correct answer, which is option number D. Correct answer is option number D. Okay. Yes, Prem and Kunal, correct answer D. Done, Eji? Done, Eji? Moving ahead to the next question then. Moving ahead to the next question then. Number 16. For the function given below, okay, the Fourier ft is Laplace inverse of 3s plus 1 upon s cube plus 4s square plus k minus 3s. Okay, what is the value of k if limit x tending, sorry, it should be limit t tending to infinity, of course, it's a function of t. If limit t tending to infinity, ft is 1. Final value theorem. It is nothing but the final value theorem. Tell me. Tell me. Chalo, yes, and if you're enjoying and if you're getting the answers and understanding the questions and concepts, do not forget to put your attendance. Yes, that is hit the like button. Yeah, correct answer for the previous one. Bhanu, Prem, Kunal, Rahul, Chinmoy, Martina. Okay, chalo, is pe aa jate. Okay, so now limit t tending to infinity. Final value theorem. Limit t tending to infinity ft can be solved as limit s tending to 0, s into fs. Final value theorem. Okay, so this becomes limit of s tending to 0, s into fs. Okay, fs, the Laplace transform is itself given, that is 3s plus 1 upon, from the denominator I can take the s common, so it's going to be s square plus 4s plus of k minus 3. Correct? So that s and s will get cancelled. Okay. Acha. So s and s cancel, s tending to 0, so 1 upon k minus 3. Now you are given that this limit is equal to 1. That means 1 upon k minus 3 equal to 1. So of course k minus 3 is also 1 and k is equal to 4. And the k is equal to 4. Option number D. K is equal to 4. Option number D. Yeah, correct answer for this. Prem, Kunal, Rahul, Subodh, Meena, Bhanu Prakash, Chinmoy. Correct answer is D. The very correct answer is D. Right? Chalo, done hai. Next question, number 17. The ROC, the region of convergence of the Z transform of a signal, is given as mod Z greater than 5. Which of the following can be poles? Very simple concept question. Which of the following can be poles? Okay, poles and ROC. Poles and ROC. क्या पता होना चाहिए आपको? ROC cannot contain any poles. The poles can't be inside ROC. Okay. So mod Z greater than 5 hai. So there should not be any pole which has mod Z greater than 5. So A is wrong. Okay. -9 nahi aa sakta. -10 nahi aa sakta. Only possible option is D. Only possible option is D. There will be a picture of this kind. There can be a picture of this kind. Okay, if I take the Z plane, okay, if I take the Z plane, and let's say this is the circle of some radius that is 5. Let us say, okay, I want to take mod Z greater than 5. So this is the ROC. Okay, ये मान लेते हैं radius 5 है. Okay, so this is the ROC, and the poles, if I have taken at -1, -3, and even at -5, it is allowed, because ROC is mod Z greater than 5. ROC is what? It is mod Z greater than 5. So -1, -3, -5 is allowed. Okay. Option number D is allowed. Option number D is very clearly allowed. Done hai ji? Okay, next question. Number 18. What is the Fourier transform? Direct question. E power minus 2t square. You should know what is the Fourier transform for e power minus 8t square. Okay. What is the Fourier transform for e power minus 8t square? The Fourier transform of the Gaussian signal e power minus 8t square has the Fourier transform equal to what? Come on, tell me quickly. And just wait a moment. Come on, tell me. Hello? It's a last question for me. ठीक है, मैं कॉल करता हूँ आपको. All right, dear. So this is the last question from my side, and Sanjay Rathi sir is going to continue further with network and log and EDC questions and concepts. Okay, after that, Saket sir will also join. So what is the Fourier transform for e power minus 2t square? For e power minus 8t square, dear, it is given by root over pi by a e power minus omega square by 4a. Okay, so यहाँ पे a का वैल्यू 2 लेना है, तो रूट ओवर पाई बाई 2 e पावर माइनस ओमेगा स्क्वायर बाय 4 2 जा 8. ऑप्शन नंबर ए. Option number A. Yes, Martin and Bhanu, correct answer. Chinmoy, correct answer. Okay. Root over pi by 2 e power minus omega square by 8. ठीक है, a की जगह 2 रख देना है आपको, तो ये 2 and 4 2 are 8. Option number A. That's it. Option number A. That's it. ठीक है guys. चलो, done है जी. Okay. So stay connected in the Telegram, and also guys, just today, that is 6th of September at 7:30 p.m. Okay, all those, okay, preparing for any competitive exam, GATE, ESE, or anywhere else, you know, maths play a very important role, and especially in GATE, it has the weightage of 13 marks, and as engineers, you can really target 13 out of 13 if you apply the proper methods and measures. Okay, so what are the tips and techniques to score full in engineering mathematics? There is a free live workshop that is today on the BYJU'S exam prep app. You can download the app if you don't have it from the Google Play Store, and you can join me live at 7:30 p.m. okay, to discuss about engineering mathematics tips and tricks. And also guys, coming Sunday, that is 10th September, okay, you can appear in the BYJU'S National Scholarship Test. Yes, if you want to take a next step towards your journey of GATE preparation, and if you want financial assistance, you can get up to 90% scholarships if you just prove yourself in this scholarship test. That is this Sunday, starting from 9 a.m. You can again register for this on the BYJU'S exam prep app. Okay, so as I told you, I'll also share you the link of my Telegram. I shall share it directly in the chat box. Okay, so that whatever questions we are discussing, you get the PDF of this. Let me just share it up. Just a moment. And then let me invite after this. Just a second here. Where is it? Here it is, guys. You can join my Telegram group and you'll get the PDF and everything else there. Okay, that's it. So yeah, let me call upon Sanjay Rathi sir now. Okay, let me call upon Sanjay Rathi sir just in a moment, and he's going to continue with network and log and EDC questions. Okay, after that, Saket sir will also join. Okay, so just a moment, dear. Hello. Sir, मैं stop कर दूं?
Hello everyone, very good evening and welcome to the BYJU'S exam prep. How are you guys? Let me know that sound and picture quality, everything is fine. Yes, please. Give me 1 minute. Okay, I think everything is fine. Okay, very good afternoon, Bhanu Prakash. How are you, Chinmay and all other students? And what about your preparation for HAL exam? Going well? So guys, this is the HAL 2023, the end game, super fast, non-stop questions. And thank you, Rakesh sir. Already Rakesh sir have taken some number of important questions. Now this is my turn and I am going to cover 3 subjects, EDC, analog and what? Network. Okay then. So quickly, we will solve some questions, and for new students, that is my introduction. Myself Sanjay Rathi. I am an ex-IES and 22 years of teaching experience. And during these 22 years, I have mentored more than 1 lakh students for these competitive exams. Right? So according to my experience, you have to attempt all the questions and try to avoid what silly mistakes, guys. Okay? Now, this is my Telegram channel. After this session, I will upload the PDF of this session on this Telegram channel, that is Electronics by Sanjay Rathi. And daily I am posting one question to improve your concept, daily dose to improve your concepts, and latest information about exam. So if you want each and everything, if you want to clear your doubts, then you can join this Telegram channel, that is Electronics by Sanjay Rathi. Okay? And guys, you can download the BYJU'S exam prep app. तो कितने लोगों ने डाउनलोड कर लिया? यहाँ देखिए, number of papers are available, mock tests are available for GATE examination, for engineering services and other competitive exams. First of all, install from Google Play Store and then give mock test, okay, and get the idea about these papers. Then now, as this is the first question from network, tell me what is the answer for this one. What is the answer for this question? The power supplied by the DC voltage source in the circuit shown below is. Power supplied by. Then what is the answer for this one? Power supplied by the DC voltage source in the circuit shown below is. This is the 6, this is the 3, this is the 1, this is the 3 volt, it is connected here. Then what is the power supplied by the 3 volt battery? Very, very simple question. This type of questions you may expect in exam. Okay, try to solve 0 watt, 1 watt, 2.5 watt and 3 watt. Network or circuit theory. Then this is the circuit. First of all, find the equivalent resistor here. What is the equivalent resistor here? Okay. So ask your friend to join the session, guys, everyone. So Rahul has given the answer 3, that is the D. Yes, that is the correct answer. Then what is this? 6 parallel with 3. Remember, it is 2 and 1, it is in series. So what is the R equivalent? 6 parallel with 3 plus 1, that is what? 3. So what is the current given by this battery? The current given by this battery is 3 divided by R equivalent, that is 1 ampere. So what is the power delivered by this battery? 1 into 3. Power is equal to V into I, that is equal to 3 into 1, so 3 watt. Because current enter through the negative leaving the positive, that's why this is the power delivered by the battery, right? So that is the 3 watt is the answer for this question. Next one. Good. Next question. This is the answer D. Next question. Consider the circuit shown in the figure, the magnitude of the ratio of the currents I1 by I2. What is the magnitude of the current I1 by I2? This is the 2, 5, 3, 4 and then 4 ohm, 3 ohm, 5 ohm, 2 volt battery is connected here. 2 volt battery is connected here and here we are getting the I1, here we are getting the I2. So what is the ratio of I1 by I2? Magnitude. Means we have to give the positive value. So what is the answer for this question? So there will be what? 4 options for that, right? This is 2, 5, 1 and 10. Now tell me which answer is correct. 2, 5, 1, 10. 2, 5, 1, 10. Yes, tell me. Now some student will try to solve it. This is the 5, this is the 3, 4 parallel with 3 and then 5, then what is the current distribution and so on. But here we can apply one theorem. What is the name of the theorem? What is the name of the theorem? That is, we can apply reciprocity theorem. We can apply what? Reciprocity theorem here. 2 volt, what is the response here? I1. What is the excitation here? V1 is equal to I2 upon V2. Right? So I1 upon 2 is equal to what? I2 upon 2. Both are 2, 2, 2, 2 cancel. So what is the I1 by I2 or I2 by I1? 1. 1. So we can simply apply the reciprocity theorem and you will get the answer. No need to solve it. No need to solve or no need to find the value of I1 and I2. In both the cases, we will get the same answer. So this is called reciprocity theorem and that's why answer C is correct. Answer C is correct. Now next question. For the circuit shown below, right, watch this third question. For the circuit shown below, the voltage across the capacitor is. What is the voltage across the capacitor? Right? This is given minus J100. This is J100. What is the impedance because of the inductor? J100 ohm. What is the impedance because of the capacitor? Minus J100 ohm. And this is the 10 ohm. And the voltage given is the 10 volt. Voltage given is 10 volt with 0 phase. Now tell me, what is the voltage across the capacitor? Which answer is correct here? Very, very easy question. Directly you can solve this. Yes, please tell me. What is the answer for this question? Chinmay Rai, Rahul, Anu Prakash. Okay, give me the answer. Then, if you have subscribed the channel, it is okay. If not, then subscribe the channel because we are going to take number of sessions on same channel. Now countdown for GATE 2024 already started and we have number of exams. So daily, so that you will get the notification about all our sessions. And join Telegram channel where we will upload the PDF of all this. Okay, what is the answer for this question? Now, watch this. This is what? ZC. This is what? ZL. So what is the magnitude of ZC and ZL? Equal. ZC and ZL are equal. If the ZC and ZL are equal means circuit is in resonance. The circuit is in resonance. So what is the overall impedance? 10 plus J100 minus J100. It is only 10. This is purely resistive. If it is purely resistive, then what will be the current? Then current is given by V by Z. What is the V by Z? 10 by 10. 10 by 10. So what is the current here? 1 ampere. When the 1 ampere current, it is in the phase with what? This battery. Why phase? Because it is in resonance. In resonance, the phase difference between current and voltage is what? 0. These two are in same phase. Now this current when passed through the capacitor, what is the voltage across the capacitor? What is the voltage across the capacitor? This current is 1 ampere. Angle is 0 because its angle is 0. Now what is the voltage across the capacitor? I into ZC. So 1 into minus J100. This is nothing but minus J100 volt. Minus J100 volt. So which answer is correct? This one. Real part is 0. Imaginary part D. So first of all, when we are getting the RLC circuit, always remember, first of all, check what? Resonance. Whether the circuit is in resonance, yes or no. When we are dealing with the sinusoidal signal. If it is a DC signal, then we have to find whether the response is underdamped, overdamped, critically damped and so on. So this is the AC signal. So AC signal, first of all, check what? It is a steady state analysis of sinusoidal signal. Remember, what is this? Steady state analysis of sinusoidal signal. Now, next. So that answer is D. Circuit is under resonance. Next one. Now the DC voltage gain. What is written here? DC voltage gain V0 by Vi in the following circuit is given by. What is the DC voltage gain? Then the DC voltage gain, this is R1, this is the V, this is Vi, it is input. Voltage gain means V0 by Vi. So which answer is correct? A, B, C or D? Watch answer carefully and give me the answer. Right? So Martina, for 20 you have given the answer D. That is correct one. Now what is the question about 20 or 21? This is 21. What, 1 minute? That is the answer for 21. Again D. Right? 21, that is the answer D. Then 22. This question is 22. Yes, please. Then watch this. If you want V naught upon Vi, voltage gain V naught upon Vi, then this is V naught. So what is the V naught? Since it is open circuit, what is the current here? 0. What is the drop across R naught? 0. So AVV. AVV. Now what is V? R2 upon voltage division rule. R2 upon R1 plus R2 into Vi. Put here. V naught is equal to AV R2 upon R1 plus R2 into Vi. So what is the V naught by Vi? So V naught by Vi is nothing but AV into R2 upon R1 plus R2. So that's why. So what is the answer for this question? V naught by Vi is given by AV. It is a 0 degree phase shift because it is plus, it is minus. R2 upon R1 plus R2. This is the answer. So which answer is correct? The number of students have given right. Rahul, Bhanu Prakash, your answers are correct. Answer is A. Answer is what? A. Now remember, internal gain is A, but overall gain is AV. But overall gain is AV R2 upon R1 plus R2. Then next question. Now, questions from transient. Question from what? Transient. In the circuit shown in the figure below, this is the circuit shown in the figure below, 1 volt, 1 ohm, 1 Henry inductor is connected. Switch S is closed at T equal to 0. The switch is closed at T equal to 0. Means initially the switch was open. Which one of the following gives expression for voltage across the inductance as a function of time? Voltage. This time we have to find the voltage, not current. So read question carefully. Voltage across the inductance. Now tell me what will be the answer? Voltage across the inductance. Everyone. Now inductor does not allow sudden change of current, right? So inductor does not allow sudden change of current. So it is when the switch was open, what is the initial current through the inductor? 0. I0 negative is equal to I0 positive is equal to 0. Unenergized inductor. So unenergized inductor, so exactly at T equal to 0, inductor does not allow sudden change of current. Therefore inductor acts as open circuit. Initially inductor acts as open circuit. So what is the initial voltage across the inductor? Remember, initial voltage across the inductor is 1 volt. 1 volt. This is the initial voltage across the inductor. And exactly at T equal to infinite, inductor acts as what? Short circuit. So what is the final voltage across the inductor? Final voltage across the inductor at T equal to infinite, inductor acts as short circuit. So what is the final voltage? 0. What is the time constant of the circuit? L by R. That is 1 second. So you can directly write this equation V final minus V final minus V initial e raised to power minus t by tau. What is the final value? 0. 0. What is the initial value? 1 volt. What is the time constant? 1. Then it will become e raised to power minus t. That is the voltage across the inductor. E raised to power minus t. Exponentially decreasing function. So exponentially decreasing function, which answer is correct? D. D for Delhi. Okay. The exponentially decreasing function. Now remember, Now some student will find what? Current. And then after finding the current, yes, now they can find the value of the voltage. So that is another approach. So we are finding the current IL. What is the IL? I final minus I final minus I initial e raised to power minus t by tau. What is the final value of the current? Because finally the inductor will act as short circuit. So 1 divided by 1, that is the final value of the current. 1 divided by 1, 1 ampere. This is 1 ampere. This is 1 ampere. This is 0. E raised to power minus t by 1. Time constant is 1. 1 minus e raised to power minus t. That is the IL. What is the voltage across the inductor? L di by dt. L di by dt. What is the value of the L? 1. And what is the differentiation of this? Differentiation of 1 is 0. Minus minus it will become plus. You will get minus t. So that is another approach to solve this question. But if you have the final value, if you have the initial value, but in a HAL type of exam, directly voltage is exponentially decreasing function. Straightforward, within 10 seconds you can give the answer. No need to derive it. Voltage across the inductor is exponentially decreasing function, and finally it will become 0. And that is the applied voltage Vs. In this case, Vs is 1 volt, the exponentially decreasing function. This is the time. Next question. Next one. Okay. Find the Norton's equivalent resistance of the circuit shown in the figure. Simple, very, very simple. What is the Norton's equivalent resistance? When we want to find the Norton's equivalent resistance, here, across AB. Norton's or Thevenin's resistance, then find the Norton's equivalent. Options are 78 ohm, 81 ohm, 98 ohm, 101 ohm. This is a self-test, guys. So please mark your answer. Which question? For example, 24. What is the answer? And then I will give the answer. Check your answer, whether it is right or wrong. If it is right, then okay, give marks. If it is wrong, then what? Simply work on it. What is the problem? What is the mistake? And so on. Tell me. Find the Norton's equivalent resistance. If you want to find the Norton's equivalent resistance, remember, voltage source, all are independent sources. Voltage source 0, current source 0. Means voltage source acts as short circuit, current source will act as open circuit. And find the R equivalent. Find the R equivalent. Then this one. Short circuit. Short, and this will act as open circuit. Okay, now watch this. Now this is a floating resistor, leave it. This is short circuit 40 and 20, 60 parallel with 30. So 60 parallel with 30 is nothing but 20 ohm. 20 ohm. You can check. Right? So this is the 20 ohm. Now this is 5, this is 20, this is 45, this is 8. These all are in series. And this leave it because there is no current through the 15 ohm. So this is 20, this is 5, this is 45 and this is 8. So 45 plus 25, 70, and this is what? 8. So what is the RN? 78 ohm. 78 ohm is the answer. So which answer is correct? A. But quickly you have to solve in exam. What is the Norton's equivalent resistance? Voltage source will act as short circuit. Current source will act as open circuit. Yes, Bhanu, your answer is correct. A is the correct option for this question. Now next question. Now network over. So guys, remember basic question, basics. Quickly you have to solve. Try to avoid the silly mistakes. Thevenin's theorem, Norton's theorem. Right? Theorems are important. Transient is important. Steady state analysis of sinusoidal is important. Two-port network is important. So already I have covered all the questions, but basics, right? And quickly we have to solve. So try to avoid the silly mistakes. Now, just in a EDC, this is the question from EDC, electronic devices and circuit. Which of the following is true? Silicon wafer heavily doped with boron is a P positive substrate. Silicon wafer lightly doped with boron is a P positive substrate. Silicon wafer heavily doped with arsenic is an silicon. Remember, wafer means what? This one. When we are giving heavily doped means everywhere heavily doped, P positive is used. P positive means what? Heavily doped. So this is wrong, lightly doped, this is wrong, this is lightly doped, wrong. Now heavily doped. And P type. For P type we have to give what? Trivalent impurity. Now out of A or C, which one is correct? Heavily doped arsenic. Arsenic is what? Pentavalent impurity. And boron is what? Trivalent impurity. It will accept one electron and give the holes. Then it will become P type. It is accept one electron and become negative ions and create holes. So this is what? Boron. So which of the statement is true? Option A. Option A is the correct one. Right? So semiconductor physics. Get the basic idea about what mass action law and other things. The next question. Okay. Which of the following is not associated with PN junction? Tell me. Which of the following is not associated with the PN junction? Diode. This is the PN junction. So when it is reverse bias, we are having depletion capacitance, CT. Depletion capacitance, right? And you know the formula, epsilon R A by W, where W is the depletion width, and what is the formula? Vj is equal to 2n upon 2 epsilon s W square. So this is the Vj is junction potential here, and CT, that may be another question on that, is proportional to what? 1 by root over Vj. Vj is equal to junction potential, built-in potential, plus what? Applied voltage in reverse direction. Yes, junction capacitance, depletion capacitance. Junction capacitance means diffusion and transition both. Junction capacitance means diffusion capacitance and transition capacitance both. When the diode is forward biased, then there is a diffusion capacitance. That is also called charge storage capacitance. So what is the diffusion capacitance? Tau G. Right? Tau G. Okay. Then what is the tau G means? Tau I by eta Vt. This is the formula for diffusion capacitance. So that is related, that is related, that is related. Channel length modulation, it is related to what? FET. That's why which answer is correct? Which is not associated with the PN junction? Answer D is correct. Answer D is correct. Bhanu, now it is clear? Channel length modulation is not related to what? PN junction. It is related to what? FET. Then next. Then next question. Okay. तो ये देखो, ये जो जैसे मैंने इसको एक एग्जांपल लिया है, दिस इज वन एग्जांपल. यू कैन प्रैक्टिस व्हाट 1 mark क्वेश्चन फ्रॉम गेट एग्जामिनेशन. If you are solving the previous year questions of 1 marks, we can expect the same type of questions, right? Tell me. The drain current of a MOSFET in saturation. Drain current of a MOSFET in a saturation is given by K VGS minus VT. VGS minus VT the whole square. Where K is a constant, the magnitude of the transconductance GM is. What is the magnitude of transconductance GM? So transconductance means what? In a saturation region, which formula is correct? Give me the answer A, B, C or D. Which answer is correct? A or B or C or D? Then what is the transconductance? Change in current because of change in voltage. So we can find 2 times of K VGS minus VT. This is called transconductance. Then you can watch this. The B is the correct answer. B for Bombay is the correct answer for this question, EDC. So this is the next one. Mass capacitor. Now everyone please, the question on mass capacitor, try to attempt. Mass capacitor is, just after that we will solve questions from analog. Mass capacitor is biased such that majority carriers pile up. Majority carrier pile up. Mass capacitor bias means this is the mass capacitor. Right. This is, for example, it is P type. What is the majority carrier? Holes. It is N positive, N positive. This is gate terminal. This is SiO2 layer. Majority carrier pile up at oxide semiconductor interface. So majority carrier, where the majority carrier will pile up? Okay, with the question number, Bhanu, with the question number give the answer. For 28, that is the answer. For that, this is the answer. Because otherwise, for which question you are giving the answer, that is not clear. Now everyone, majority carrier means holes are piled up here. If the holes are piled up here, means what? This is called accumulation. When the electrons are piled up, then it is called what? Inversion. So what is the answer for this question? Accumulation, D. So there are four: accumulation, depletion, inversion. Weak inversion and what? Strong inversion. So that is the characteristics, as you know. This is called accumulation. This is called depletion. This is called inversion, and that is called what? Strong inversion. This is called weak inversion. So this is nothing but accumulation. Accumulation. So answer is A. Now, अरे भाई कुछ क्वेश्चंस दीजिए, जवाब आप लोग, ये इंपॉर्टेंट है. दैट इज अ इंपॉर्टेंट क्वेश्चन गाइज. एवरीवन ट्राई टू गिव मी द आंसर and please note in your copy whether you are giving the right or wrong answer. Now, this is the concept of what? Analog as well as EDC. Tell me, integrated question, important for all branches. An NPN bipolar junction transistor is operating in the active region, right? NPN bipolar transistor is operated in active region. Active region means we can design amplifier by using BJT. If the reverse bias across the base collector junction is increased, this is BJT. Reverse bias across base collector junction is increased. This is the reverse bias. Then what will happen? So, my dear friends, it is asking about what? Early effect. It is asking about early effect. Early effect means when we are increasing the reverse bias, depletion width increases. When the depletion width increases, recombination decreases, current gain increases. So depletion width increases in the base region, as you know. This is emitter region, base collector. When we are making it more and more reverse bias, what happens? The depletion width increases in the base region. When depletion width increases, what is the effective base width? Where the recombination occur, decreases. Because here we are having the electrons. In depletion region, there is no mobile charge carriers. When the hole enter, it will recombine in this region only. When the recombination decreases, current enter into this area increases. That is called alpha IC. Alpha I, that is IC. Means ultimately IC increases. And remember, if alpha increases means what? Beta increases. Because what is the beta? Alpha upon 1 minus alpha. So beta, alpha increases means beta also increases. Now which answer is correct? Effective base width where recombination occur increases. Wrong. Effective base width increases. Wrong. Effective base width decreases and common emitter current gain increases. Right. Effective base width decreases and the common emitter base current gain decreases. Wrong. So answer for this question is C. So Martina, you have given the right answer. 29th answer is what? C. That is called early effect, base width modulation. That is important. The next one. Okay. After that, we will discuss the question of what? Analog. 6 questions from analog, and please stay tuned with us, because after me, Saket Verma sir will join, right? So then the intrinsic carrier density at 300 degree Kelvin is 1.5 into 10 raised to power 10. 1.5 into 10. Everyone try to solve this question. This is the standard value. For n-type doped to n-type silicon doped to means Nd. For n-type we are giving the donor impurity 2.25 into 10 raised to power 15. The equilibrium electron and hole densities are equilibrium condition. And give me the name. What is the name we are going to apply? Which theorem or which law we are going to apply? Then remember, this is a bar. We are giving the Nd type doping, and this Nd is very greater than what? Ni. Every donor atom will donate 1 electron and will become positive ion. Positive ion is positive ion electron, and this is very high as compared to what? Intrinsic carrier concentration. That's why what is the concentration of electron? Nearly equal to Nd. Then what is the concentration of hole? According to mass action law, Np is equal to Ni square. So what is the concentration of hole? Ni square by N. That is 1.5 into 10 raised to power 10 square upon what? 2.25 into 2.25 into 10 to the power 15. 1.5 square is 2.25. It will become 2.25 into 10 to the power 20 divided by 2.25 into 10 to the power 15. You will get 10 to the power 5. This is called minority charge carrier. So minority charge carrier. So what is the concentration of electron? 2.25 into 10 to the power 15, and concentration of hole 1 into 10 to the power 5. C is the correct answer. So we are just applying the mass action law. Yes, Bhanu, your answer is correct. Mass action law. C is the answer for this question. Right, or always remember it, if Nd is very greater than Ni, then directly you can say N is nearly equal to Nd and Np is equal to Ni square. Directly you can apply. Next question. Next one. Question from analog. Question from analog. First question. Okay, this is OPM, your favorite topic, everyone. Give me the answer. The magnitude of gain in inverting V0 by Vi. This is the inverting operational amplifier shown in the figure. Is X. No. The magnitude of the gain V0 by Vi. This is the question. The magnitude of the gain V0 by Vi in the inverting op-amp circuit shown in the figure is X with the switch S open. When the switch S is closed, the magnitude of the gain will be. When there is no switch, the gain is X. Then what? What is the answer? One student have given the B. Yes, Manoj Kumar Martina, you have given the answer B. All other students try to give me the answer. Okay. Yes, please. Now, when the switch is open, what is the switch is open means? Watch it. There is no switch. So what is the gain for inverting operational amplifier? Magnitude. It is asked about the magnitude. RF by R1. What is the RF here? 2R. This is called RF. 2R upon R. That is nothing but 2. Or this 2 is what? X. This 2 is equivalent to what? X. Okay. Now when this resistor is gone, it is short circuited. What is the RF now? When the switch is open, That is the gain. When the switch is closed, it will short circuit the resistor, then RF is equal to R only. So what is the gain? R by R, that will become 1, and that is nothing but X by 2, because X is equal to 2. So answer is X by 2. B. X by 2. Very, very true. You have given the correct answer. Next. Okay. Consider the following circuit. What is the function of diode D2 in the above circuit? And tell me what is the name of this circuit, everyone. We are connecting the two diodes D1 and D2. This is R and this is R. What is the purpose of diode D2? What is the basic purpose of diode D2? Right? What is the basic purpose of diode D2 in the figure? Right? Now, remember, please give me the answer. To avoid saturation of the op-amp, to provide negative feedback when the input is negative, to reduce the reverse breakdown voltage, and as the buffer. So there are 4 options. So quickly we can give the answer because it is a standard circuit. Now, okay, read this question, take a screenshot of that, and just I'm giving you the answer for this one. Remember this one. This is actually precision rectifier. So we are just connecting the two diodes here. First diode is here, this one D1. This is the same diagram. This is V0. This is D1. This is D2. R, V in. So it is a precision rectifier, right? Now, what is the purpose of this diode? Try to understand. Initially, this diode was not present here. What will happen? This is responsible for the rectification, right? This is responsible for the rectification. But when this diode was off, PIV was very, very high. PIV, peak inverse voltage, because when this diode is off, there is no negative feedback. When there was no negative feedback, what will happen? Operational amplifier will goes into the saturation. Operational amplifier will goes into the saturation because there is no feedback. There is no negative feedback. So what is the under saturation? This voltage is very, very high. For example, minus V set. And that's why what is the PIV for this diode? Very large. This is 0 volt and this is reverse bias by minus 15 volt. Peak inverse voltage or the voltage coming across the diode in reverse direction is very, very high. Now, how we can reduce this PIV? Simply by avoiding what? Saturation. To avoid the saturation, what we are doing? We are connecting a diode here in feedback path. We are connecting a diode here. When this diode is off, because of this negative value, this diode is on. And because of this negative feedback, operational amplifier will never enter into what? Saturation. So that is the purpose. It will avoid the saturation. But I want to ask, what is the basic purpose? No doubt, it is to avoid the saturation of the operational amplifier. But the basic purpose, if it is MCQ, only one answer is correct. To reduce the reverse breakdown voltage of D1. To reduce the reverse breakdown voltage of D1 by avoiding the saturation. Okay, Chinmay, it is correct? That is the question. So no doubt, if it is MSQ in GATE exam, it is a HAL paper. So HAL, one answer is correct, C. One answer is correct, C you can give. It will reduce the reverse voltage or PIV by avoiding the saturation of the operational amplifier. Okay then, so this is the C is the correct one. You have given the right, but if it is, which one is the best answer? C is the best answer. Then, precision rectifier. If they will ask what is the name of the circuit, then you can say it is a precision rectifier. Now next question. The operational amplifier circuit shown in the given figure is high pass circuit, a low pass circuit, a band pass circuit, and all pass circuit. This is R and C is connected. R and C is here. It is connected. R, C, 2. R, C. What is this? High pass filter, low pass filter, band pass filter, all pass filter. Tell me. If these two resistors are equal R, then it is what? All pass. Now if it is RC circuit here, then what is this? So 33B, Bhanu Prakash, B for Bombay, okay, low pass filter. Yes. So my dear friend, it is actually a low pass filter. It will pass the low frequency and it will block the high frequency signal, right? Now you can check here for low pass means you can start with the frequency 0. What is the impedance because of the capacitor? 1 by omega c, magnitude, or 1 by 2 pi fc. 1 by 2 pi fc. Now for f is equal to 0, capacitor Zc will come infinite, capacitor act as open circuit, and for f is equal to infinite 0, capacitor act as what? Short circuit, open circuit. When the capacitor act as short circuit, so for high frequency this will short circuit, output will become 0. It will not pass the high frequency signal, it will pass only what? Low frequency signal. And remember, what is the standard formula for low pass filter? As you know, this is the low pass filter by using the voltage follower. This is the low pass filter. This is the C, this is the R, and this is the integrator. Again, integrator is also a low pass filter. It is also a low pass filter. No need to derive the formula. So these two are low pass filter and we are connecting just these two and we are giving the single input RC, RC. So that's why it is a low pass filter. So it is a low pass filter, guys. B. So please prepare all type of filter: low pass filter, high pass filter, band pass filter, band reject filter. Get that idea about the diagram and whether the inductor is connected or resistor is connected. Quickly you have to give the answer. Okay. CSE gate exam. CSE means what? Computer science engineering. Then it is not related. Not related, Marcus Hill. Sorry for that. Sorry for inconvenience. It is an analog. If you are going for what? Two paper choice, computer science and electronics, computer science or electrical, then it is important for you. Okay, tell me. Now what is the answer for the next one? Assume the diodes in the circuit are ideal. The current Ix, this is the current Ix. Right, tell me what is the answer? What is the answer for this question? So this type of questions, again, in gate 1 mark question, but it is a no doubt 2 mark question in gate examination, but it quickly you can solve. Quickly you can solve this type of questions. 15, 10, 15, 15, 10, 5 volt. There are 3 diodes, D1, D2, D3, then 2 and 3, 2 and 2 kilo ohm. This is the 12 volt, this is the 6 volt. What is the answer? So, okay, give me the answer for this one. Give me the answer for this particular question only. Okay, tell me, what will be the answer? Now, to this type of questions you have to practice. Now we have 1 or 2 days. So if you have time, then you can solve the previous year question. But easy question. If suppose the calculation is very lengthy, then try to avoid all those questions. Now watch this. On the positive side, there are 3 diodes connected in parallel. So which one has the highest voltage? Which one has the highest voltage? That will be forward bias. It is on. And when it is on, it will act as short circuit. This is the 15 volt. Because of this 15 volt, it is 10 volt, it is off. It is 15 volt, it is 5 volt, it is off. Only this diode is on. Okay. Or on the negative side, which one is the more reverse bias? 12 volt is more reverse bias. That's why the 6 volt is on. This is on. This is off. Because it is more reverse bias, that's why it is off. This is on. Now, what is the path? This is the path. Current will flow like this. Current will flow like this. What is the current here? 15 minus 6 upon 3 plus 2, 5. 9 by 5 milliampere. 9 by 5 milliampere. Okay. Now, you can also check whether it is right or wrong. Now, what is the current here? 9 by 5 milliampere. So, this is the 15 volt. What is the drop here? 9 into 3 divided by what? 5. Now, 27 divided by 5, this is the drop. You can also check that this voltage is less than 12 volt, that's why this diode is off, and this is greater than 6 volt, that's why this diode is on. You can verify it. You can verify it. So that is the question. Simply you have to find the answer. Yes, it is okay. So what is the voltage at this point? Tell me. This voltage at this point is 927 by 5. So what is the voltage at this point? Like this is the Vx. Vx will become 15 minus drop across this resistor. That is 15 minus 27 divided by 5. And this will become 5.4. 9.6. So 9.6 is less than 12. That's why this diode is off. 9.6 is greater than 6. That's why this diode is on. Our assumptions is correct. And you will get this amount of current. 9 by 5. 1.8 milliampere. They will provide you the 4 options. This is the milliampere. Remember, it is a milliampere. Okay. The next question. Next one. Now tell me. Consider the following statement. Which one is correct? Consider the following statement. Which one is correct? Bias stability of an emitter bias amplifier circuit improves by. Bias stability of an emitter bias amplifier circuit improves by decreasing the value of RB, increasing the value of RE, decreasing the value of RE, increasing the value of RB, increasing the value of RC. Which of the statements are correct? Right. Okay, tell me. Now please stay tuned with us, because after this question I have one more question, and then the Saket Verma sir will join. Okay. So tell me what is the answer for this question, everyone. Tell me what is the answer for this one. Please tell me what is the answer. So consider the following statement. Means what? Emitter bias. So emitter bias means what? Self bias circuit. This is also called emitter bias circuit. And this is the resistors RB. This is RE. This is called self bias circuit where RE is connected. So what is the stability factor for this? 1 plus RB by RE. Approximated formula is 1 plus RB by RE. And ideal value of S is what? 1. So how we are going to get 1 when RB by RE is 0? So when RB decreases, RE increases, S decreases, stability factor decreases and stability increases. So we have to decrease the RB and we have to increase the value of what? RE, 1 by 2. That is 1 plus. Remember, this is the formula. 1 plus RB by RE. So directly on the base of formula, they will give the question. Which answer is correct? A. 1 and 2. 1 and 2. 35. Bhanu, you have given the right answer. Last question. So stay tuned because Saket sir will join. Okay. Then a good trans impedance amplifier has trans impedance. There are 4 types of amplifier: voltage amplifier, current amplifier, trans conductance and trans impedance amplifier. Trans admittance or trans impedance. So voltage amplifier, current amplifier, trans admittance, trans impedance amplifier. Tell me, what is the trans impedance amplifier? Means that is the Z. Means what? Here we are giving the current and current is converted into voltage. So that is called trans impedance. Voltage upon current is nothing but impedance. Now if at the input we are giving the current, when we are applying the current source, then the input resistance of the amplifier should be as low as possible. Why? So that the complete current will enter into the amplifier. Complete current should enter into the amplifier. So what is the Ri? It is very less than Rs. Now, here we are having the amplification that is converted into what? Voltage. That is converted into voltage. This is voltage. Now here we are having the output resistance in series, and we want that complete voltage should be transferred to what? RL. When the complete voltage will transfer to RL, when R0 is 0 or R0 is very less than what? RL, then this complete voltage will transfer to RL and there is no drop across R0. So this is called trans impedance amplifier. So trans impedance means input resistance should be low, output resistance should be low. So input low, output low. Which answer is correct? Low input impedance, low output impedance. D. This is the input impedance. It is the output impedance or resistance to transfer the current here, to transfer the voltage here, and that is called trans impedance, because V0 by Vi, V0 by I is equal to Z. Okay, I think now it is clear to you, everyone. So this is the last question from analog. Now this is my Telegram channel. I will upload the PDF of this session, as well as already I have uploaded the PDF of EDC network part 1, network part 2 for IISc Bangalore. So everything will be available on my Telegram channel, that is Electronics by Sanjay Rathi. And second important thing, if you want to ask some doubts and some notes, if you want to get the notification about any session, then that will be available on my Telegram channel. So you are on BYJU'S exam prep, the most comprehensive app for all competitive exams. Stay tuned with me and stay tuned with this session, guys. Okay, give me 1 minute only. Within 10 seconds, Saket sir will join.
Hello.
And stay tuned with this session, guys. Okay, give me 1 minute only. Within 10 seconds, Saket sir will join.
Hello, good evening, everyone. Yes, good afternoon. In fact, it is up to 2 o'clock right now. So, we are going to solve the questions of the subject EMFT. Okay, so we are going to start the questions from the other subjects. Now, you have already solved the 36 questions, so the remaining 13 to 14 questions we will solve together. And before starting the session, let me tell you about my Telegram group. So you can join my Telegram group, and the name of the group is just Electronic by Saket Sir. Okay, so you can just go for this particular and search by the name Electronics by Saket Sir. And the group name is Study with Saket. This is not there. When you search in the Telegram, the link is Study with Saket. Okay, where you will get the improvement concepts also and the latest information about the upcoming classes, etc. So let's solve this question. This is the first question, guys, and I will give you the, as I always give you the time to solve the question. So the time I will provide you to solve the question is around 1 hour, 1 minute 30 seconds. Okay, so 1 minute 30 second I will give you to solve this problem. Though it is more because the time you will get in the exam will be only 1 minute, but I am giving you 30 seconds more. So answer this question, guys. The magnetic field intensity of a plane wave is given by this, and you have 45 seconds left. Answer the question number 37. Answer the question number 37. Yes, 10 seconds left. Come on, Bhanu, Marcus, Martina, Chinmay. So the time is over now. 50,000 T plus 0.004x plus 30 is given. The bracket is closed here. Now the d theta by dt we will calculate, and it will be 0 because the phase should be constant. So this is 50,000 plus 0.004 into dx upon dt. Okay, then we will calculate this dx upon dt is minus 50,000 divided by 0.004. You will get minus 1.25 into 10 to the power 7. Yes, the answer is option C. Correct. Now let's solve the second question. So again, 1.5 minutes I am giving you to solve this problem. The electric field component of a wave in a free space is given by this. Following is the possible inferences. What are the statements that are correct? What are the different statements that are correct? Let's answer this question. I am giving you 1.5 minutes for each question, and that is more than sufficient actually. Thirty-eight. You are getting A. All the statements correct. Oh, sorry. Your answer is wrong. Because here you can see that if you compare it with the standard result, this is E naught e to the power minus alpha z and cos of omega t plus beta z a y cap. So wave propagates in the minus z direction. Okay, wave propagates in the minus z direction. So first statement is correct, incorrect. Lambda is equal to 2 pi by beta, or you can also write it as C upon F. So this is C is free space, so it is 3 into 10 to the power 8 divided by F. F is nothing but a 10 to the power 7 divided by 2 pi. So here you will get 30 into 2 pi. So that is 60 pi. So that is you are getting 188.5. That is correct. Amplitude of the electric field is 10, so that is also correct. Here you can compare. And wave number is beta is equal to 2 pi by lambda. 2 pi, lambda is 60 pi, so you are getting 1 upon 30, so you are getting 0.033, but it is 0.33 given, so it is incorrect. Wave attenuates as it travels, so alpha is 0. When you compare it here, then the alpha is 0, so there is no attenuation, so that is also incorrect. So the correct statement are 2 and 3. Yes, 38B. Now answer this one. You have to tell the phase difference between the conduction current and the displacement current. Phase difference between the conduction current and the displacement current. Come on, last 30 seconds. Okay, so now you know that the conduction current density, if I talk about the conduction current density, then it is given as sigma into E. Okay, and if I write the displacement current density, then it is written as del D upon del T. So which can be also written as epsilon into del upon del T into E. So del upon del T can be written as j omega into E. So here you can see that there is no complex term in the JC and there is a complex term which is J. It is like this, na? So here it is J. So the phase difference is 90°. There is a phase difference of 90° because of this J. So answer is C. Next. If the phase velocity of a plane wave in a perfect dielectric is 0.4 times of the free space, then what is the relative permittivity in the dielectric? 40A. Okay, last 13 seconds. So here you can see that the phase velocity is 0.4 times of c. Phase velocity is given by 1 upon root over mu naught or mu epsilon, right? And in case of free space, it is 1 upon mu naught into epsilon naught. So we will assume the non-magnetic field. So it is 1 upon mu naught into epsilon naught, and here it is mu r into epsilon r, and this is 0.4 divided by root over mu naught into epsilon naught. So it is equal to epsilon r. It will give you epsilon r is equal to 10 by 4, that is 100 upon 20, 100 upon 16, or you can say simply 5 by 2. So it is whole square. So 2.5 whole square will give you 6.25. So answer is option A. Yes, correct. 6.25. Okay, this epsilon naught will get cancelled, and I am squaring it both the side, so I will get the 10 by 4 whole square. Now coming to the next one. So last 40 seconds. A plane wave in a free space has a magnetic field intensity 0.2 in the y direction. The wave is propagating in the z direction. Frequency is 3 gigahertz. The wave and the amplitude, the wavelength and the amplitude of electric field. The wavelength and the amplitude of electric field you have to calculate. So the wavelength is lambda is equal to, okay, this lambda is equal to c upon f because it is a free space. So this is 3 into 10 to the power 8 divided by 3 into 10 to the power 9. So it is 0.1 meter, and we want to calculate the electric field. So this is eta naught into h. Eta naught because it is free space. So this is 377 and h is 0.2. So if I consider it the 377 in divide by 5, so it is 5 into 7, 35 to 75 to 75.4. So answer is option B. Yes. Now answer this one. The velocity of the electromagnetic wave in free space is 3 into 10 to the power 8. The velocity in the medium of epsilon r is equal to 4.5. Just wait a second, guys. Hello? Hello? Are you getting? What is the answer you are getting? Yes, last 1 second. So we have got this. The velocity is given by, just now we saw 1 upon root over mu epsilon. So if I put 1 upon root over mu naught epsilon naught and 1 upon mu r epsilon r, then this is given by the velocity of light and this will be mu r into epsilon r. So when we put the mu r into epsilon r, we will get root over 9. So here it is 3 into 10 raised to power 8 divided by 3. So we will get 10 to the power 8. Answer option A. Yes, 42A. Correct. Now answer this one. Yes, answer this question. Transverse electromagnetic wave are characterized by. How do you define the transverse electromagnetic wave? Yes, last 50 seconds left, guys. Come on. What is the answer of question number 43? It is the 30-second question actually. Just it takes time to read the question, and once you read the question completely, you will be able to answer this question. Forty-three B, correct. The correct answer is 43B because we know that the electric field, direction of propagation, and direction of magnetic field all are perpendicular to each other. So when the wave is traveling in the z direction, magnetic field is having electric field and magnetic field both are perpendicular to the direction of propagation. Answer is B, correct. Yes, Sonali, correct. Chinmay, correct. Now answer this question, guys. Now there are more students to participate other than the Bhanu. What is the relation between the electric field, magnetic field, and the vector magnetic potential? So you should know that the magnetic flux density B is equal to curl of magnetic vector potential. So if you will calculate the curl, this is AX plus AY plus AZ. So this is del upon del X, del upon del Y, and del upon del Z. Here you have the value AX and sine term, and other values are 0. So when you calculate it, okay, when you calculate it, you will only get in terms of, when you calculate in terms of y. Okay, so that is minus of ay. We will get minus of ay del upon del z. So when you will differentiate it with respect to z, it is ax into beta and then cos of omega t minus beta z. This is your b. Okay. Yes, Bhanu. So how did you calculate it? Because this, what about this b? When you differentiated it with respect to z, you will get del upon this one, del upon del x minus of this. So minus minus will become plus, and the differentiation of sign. Yes, that's perfectly fine. So it will be minus only. Ultimately, it will come as minus. Ultimately, it will come as minus. And then we know the relation. Okay, we know the relation, that is the B is equal to, how can you write the electric field if you know the B? This is the B. Okay, we know that the curl of H AX cross AY is equal to, okay, you calculated it from the direction, but here the direction you have known. Now the direction of all these things are same. So here you cannot decide it by the direction, but yes, you can try it. The direction of the magnetic field is Y minus, and the direction of propagation is Z positive. So direction of electric field, if you want to calculate, then direction of propagation cross product with direction of magnetic field. So direction of propagation is Z, and this is minus AY. So you are going to get minus AX. So minus AX, that means you are going to get this answer or this answer. So either of these two will be correct, either A or D. Which one will be correct? Now you have to think of these two. We know that EMF is del E upon del T, del V upon del T, you can write. So think of in that way. Del B upon del T, if you will calculate, so either A or D will be the right one. If you will differentiate this, again you will get sign. So how you will get? Option A will get. In HAL there is the negative marking, yes. In HAL there is the negative marking. Now answer this one. See here, the electric angular velocity, we want to calculate angular frequency, that is omega. So we know that what is given to us? Beta. Beta is equal to omega by C. So we want to calculate omega. Omega is equal to C into beta. What is C? C is 3 into 10 to the power 8. What about the beta? Beta is 4. So answer is A. Next. The TM wave is incident normally on a perfect conductor. So perfect conductor is having eta 2 0, and the first medium is a free space, or even it is not, then the gamma is equal to eta 2 minus eta 1 divided by eta 2 plus eta 1, so it will always be minus 1. Okay, and it is asking for the electric field. So because whatever value will be eta 1 is not equal to 0, eta 2 is 0, so we can say that the eta 1 is always greater than eta 2. And whenever the eta 1 is greater, we get the electric field minimum and magnetic field maximum. So answer is option C. Okay. Now answer this one. What is the answer of this question? What is the answer of this question, guys? So here you can see that very easy one, because here you have to apply the Snell's law. So beta 1 sine theta I is equal to beta 2 sine theta t. Beta 1, that means free space omega by c. Sine 45. Beta 2 means omega by c root over epsilon r sine 30. So omega by c will get cancelled. It is 2 by root 2 is equal to epsilon r. So epsilon root over epsilon r. 1 upon 2, 2 will go here. And when we square it, epsilon r will be 2. So answer is C. Next. Question number 48. Here loss tangent we want to calculate. So tan theta is equal to sigma upon omega epsilon. So it is 1.7 into 10 to the power minus 4. This is 2 pi into 3 into 10 to the power 9. And epsilon naught is 78 epsilon naught. When you will solve it, you will get this answer. Okay. I am telling you the answer directly. Now answer this one. Here you can see that you have to calculate the reflection coefficient for the normal incidence. So reflection coefficient for the normal incidence is eta 2 minus eta 1 divided by eta 2 plus eta 1. It is air and the another dielectric. So for air it is 120 pi. So this is eta 1, and the eta 2 is 120 pi divided by root over epsilon r. So it is 60 pi. So this is nothing but a 60 pi minus 120 pi divided by 60 pi plus 120 pi. So it is minus 60 pi divided by 180 pi. So it is equal to minus 1 by 3. So 0.33 at an angle of 180 degree. Now question number 50, we have to find the polarization. Okay, so to find the polarization, the electric fields are having the different amplitude, so it is elliptically polarized. It is having the different amplitude, and there is a phase difference. There is a phase difference of 90 degree also. The phase difference is 90 degree, and they have the different amplitude, so it is elliptically polarized. Now coming to the next one, skin depth. So skin depth, this is the last question, guys. So skin depth is given by, in which case here the conductivity is 0. The conductivity is 0. So we know that the delta is equal to 1 upon alpha, and this is 1 upon pi f mu sigma, and if the sigma is 0, then the skin depth is infinite. Okay, it is infinite. So answer is B. Yes, so guys, thank you for watching this session, and you can download the BYJU'S exam prep app, because here I get the poll facility, and here you can see the leaderboard also, that how many of you are actually getting the correct answer and who is going to top in the whole test. So that's why we take these sessions in the leaderboard. So download the BYJU'S exam prep app, and in the app there are multiple free sessions running for you. And if you are preparing for gate, then we have launched the crash course for all of you, so in where we can complete the whole syllabus in the last 4 months which are left. We have approximately 150 days. So in that 150 days, we will be able to finish the complete entire syllabus of electronics and electrical. So don't forget to join this crash course, and for that you can call in this number and you can have an inquiry regarding that. And don't forget to join my Telegram group. Thank you for watching this session. Let's meet on the next session, which is today at 5 p.m. So today at 5 p.m. we have the previous year questions of signals and systems. Okay, so we are going to solve the questions of the signals and system at 5 p.m. today in this channel. So if you have not subscribed it yet, don't forget to subscribe the channel. Thank you.